Please welcome Philipp Krenn, who's going to talk about OpenTelemetry. So let's see what he needs to tell us. Welcome, Philipp.
Hola. Lunch was good? I hope everybody is not too sleepy yet, so let's see what we can do around OpenTelemetry and when we can get going. And my laptop went to sleep, which is not good. Wake up. No? I think my laptop died. Just on the spot. I definitely have a curse. Now we go. Good. So, OpenTelemetry. Just to get a quick feeling about OpenTelemetry, who is already using OpenTelemetry? Okay, that's very few. Who has heard of OpenTelemetry? Just so that I know how deep to go. Okay, that's not even half. That's way too few. We'll get there. Before diving into OpenTelemetry itself, there is this other term, observability, that everybody likes to throw around. And some people say this is observability, where you have logs, metrics, and traces, and you combine the three, and then you have all the awesomeness that you could get. Or I assume, taking a step back first, everybody knows what logs, metrics, and traces are. We'll dive a bit more into tracing because that's the least well understood. I think logs are pretty clear. Everybody knows, like, at this point in time, something happens. We write the statement out at a specific log level with a timestamp, and then we hopefully figure out what went wrong. Metrics are nice because you can get this overview of what is happening in your system, like what is the load, how many users are on your system, what is the error rate, all of these. And traces kind of change it to get this request scope thing where you see for one request, how did it behave over my entire architecture. And then you can combine them. For example, you could combine logging and tracing. So you could have a trace ID or some unique ID for every log line of one request. And then you can know for one request, these were all the log lines. So you can combine them and ideally get more value out of that combination. And then some people are saying, like, well, logs, metrics, and traces is kind of like the foundation for observability. And by the way, observability, if you ever are confused, this is how you abbreviate it, O11Y, because you're missing 11 letters, and that's Chris's sticker, which is lying around here as well. So that's the observability part. But maybe these three things are not the entire thing that you need around observability, because it's a bit like calling Formula One. It's all about gasoline, motor oil, and tires. Which is true, you will not have a single Formula One race without these three. But still, for the Formula One fans, it's maybe not just about that. On observability is kind of the same thing, that yes, you need logs, metrics, and traces to collect relevant information, but it's still not really the value or the essence of observability itself. And we'll get maybe a bit more into what it actually is. So observability is mostly a system attribute that you cannot buy. You make your system observable by figuring out what is going on. Though that little star at the end of buy means, it doesn't mean that somebody is not trying to sell you observability. So some companies are always trying to sell you observability, though you cannot buy it, though you need still tools to make it happen. So it's kind of like this weird state. And those who are confused about monitoring and observability, because most of us have been doing monitoring for a long time. Monitoring is very much like saying your bank account is overdrawn, you don't have any money left. Observability is telling you why you're out of money. It's you spent all your money on cool computer gear or on, I don't know, fancy t-shirts or whatever you spent your money on. That is observability. It just doesn't tell you you're out of money, but it tells you why and how you potentially fix it. And that's kind of what we want to have in our systems as well, not just telling us the system is down, but why it's down and how can we actually fix that. And why do we need more of this is because back in the day we had my monolith or your monolith or whatever, and it maybe was running in the cloud and it had a load balancer, and it was very simple. It had a single database, and you could just tail F your logs and you knew what was going on here. And this was kind of nice because it worked. But then we all wanted to build something fancier, and most of our architectures today look more like this. which is also nice because now you suddenly need much more tooling to figure out what is going on here anymore, because you have these 10 different services and they have various databases and one request is touching 10 different services and you don't even know what is slow or where is an error. So you need much more tooling to figure out why something might be broken. So this is much better for vendors, which is also, I'm working for one of these vendors, and I don't want to go too much into that, but we do have tools around that as well. So why do we need that, or how does it solve the problem? Tracing, or APM, Application Performance Monitoring, I won't make a huge difference between the two terms. Some people try to make a big difference around them, but I don't really like that. Or I don't think there's much point to that, is basically you have a request coming in and you want to figure out how did that request behave throughout the entire system that I'm trying to observe here. And what you want to have is you want to have this flow of how a request shaped, how do you generate the final response, where did you spend your time, and you want to be able to reconstruct that flow and also be able to visualize what is going on, where did you spend your time, where did errors happen. That is kind of like the idea here. So it might look something like this. This is super simple. You have an OpenTelemetry newsletter service where you can subscribe to the newsletter, and when you subscribe, you get added to Redis, which stores that you are subscribed to the newsletter, and then maybe later we send you that newsletter. And the idea here is you have the request, you know which service is doing what basically, and you can see here like how many times was this requested and how much time did you spend in each request. And each one of those is like a few milliseconds only. You can see where did you spend most time. So Redis is actually the slowest thing with 1.7 milliseconds here. This is kind of like the idea. You want to see what is being called, where do you spend your time, and to debug if something goes wrong or something is slow. And then to do that, you need language-specific agents to instrument your applications. And they detect when did the request start and end, and where did it error, and where did it spend its time overall. The agents are generally where the meat is, or where kind of like what is the smart thing. So an agent for a specific programming language needs to understand what are the base libraries or frameworks that you're building on here. So for example, let's say you're using Java, and you're using JDBC to do a database query. So that agent needs to understand what is a JDBC query, and then can store that SQL query in the background to actually see what was the database query, how long did it take, that you can actually figure out where do you spend your time and what is going on here. Don't be shy, there are seats in front, you can come up, you don't have to stand. The idea of agent is you have little or no overhead, so it's not profiling, which you sometimes do like JVM profiling, where you attach to the process, which has a lot of overhead. But an agent generally runs all the time because you want to extract that knowledge and value from the running application at all times. And then you have distributed tracing, which basically has, if you have this multi-service architecture, that you want to be able to follow a request not just within a single service, but across many services. So basically, it is a directed acyclic graph, which is like the request comes in, and then it basically touches maybe multiple of your microservices, and at the end, you give the response back. So it has this entire graph of requests and how long it took, where you spent your time. A span is like a method call or one unit of work, where you want to figure out how long did I spend in this part. And then context propagation is, since you have multiple services, you need to generate a unique ID when the request comes first in, and then you keep that unique ID as it kind of like works its way throughout the entire system. And it might look something like this. Here I have two services, service A and service B, and you can see there is the parent span, the initial thing that you call, and then it has other things that it calls to generate that response. It also reaches out to service B to get you the response back. And all of that is that one trace. And you can also nicely see how logs actually play into that. Because logs are very component-based, or it's like a log statement is really at this point in the code, this happens. But it doesn't tell you so much over the entire request. The entire request is best answered by tracing. So this is kind of like the main difference here. The problem behind this is that different tracing systems use different IDs to propagate throughout the system and know what one request is. Which system is UberTrace ID? Which part is using that? Jaeger, yes, Uber created Jaeger, and that's like why their header is still Uber Trace ID, but that's generally how the Jaeger trace IDs look like. For example, we have our own instrumentation, which has a totally different format. The problem is those two don't play well together because they just look totally different and they cannot interact. And that was when people said, like, isn't that kind of dumb that every application kind of like needs to be instrumented with the same instrumentation? Maybe one tool doesn't support like an iOS client and you cannot then instrument the application down to that level. So why do we have these different headers? Why don't we standardize on one header to make that work? And that's what OpenTracing did, which is dead by now, but it was the first initiative to actually combine like those header problems into a single standard, which is basically a vendor-neutral thing, how those headers can be named. And it can confine or define how the so-called span context looks like. You see there is a trace ID, and then there's a span ID, and then baggage items are basically key value pairs of additional information that you can attach where they happen in the request. And that was the standardization, which is very simple, but it still lets different agents, in theory at least, interoperate to some degree because the IDs match up now. The problem is OpenTracing was very limited. It only provides an API or headers. It does not provide any wire protocol. So it doesn't specify that the agent of one vendor can talk to the wire protocol of another vendor. So the wire protocol can be either in-band or out-band. In-band is the propagation of the headers, and out-band is actually the centralization of the data that the agents collect. So those didn't match. And to fix that, W3C started another standard, which is Trace-Context, that you can actually propagate this information from one agent to another, which looked slightly different, but did the same thing. But this was, again, only a step, or it's still in there, but kind of like the next step after that was then OpenTelemetry. And OpenTelemetry is going one step further. So at first, we had OpenTracing, which just had the headers or IDs. And then we had the wire protocol in trace context, and then OpenTelemetry is going even further by saying we also specify how the out-band protocol looks like, and we even have standardized agents that you can use across vendors and instrument your applications with that open standard. It's an open source project running under the Cloud Native Foundation. It tries to not only do tracing, but also metrics and logs and potentially more things. We'll get to that at the end. And it basically replaces OpenTraces and OpenSensus. OpenSensus was a Google implementation that was kind of widely used in the Google ecosystem, but if you were not there, you probably haven't seen it. But OpenTelemetry is, in any case, the new standard that everybody tries to use. And it's basically unifying how you can collect the data and then send it out of the system. It's vendor neutral, but driven by many different vendors. So from New Relic, Splunk, Honeycomb, Elastic, and many others are in there contributing together to have a standardized agent and like API specification. And then you still have the different vendors in the backend to store the actual information. And those standards are at different maturity levels. So tracing is where it started and what is the most mature and what you can do today. And I think that's also almost the standard or where most are converging nowadays. Metrics are stable from the API. The implementation in the different agents is mostly stable, like Java, JavaScript, Python, and .NET I think is stable, and the other programming languages that are supported are coming there. Logs is still in a draft state, so the logging standard is not really, you can use it, but it's kind of like still not finalized yet. So tracing is the thing where to start, and that's why I will focus mostly on that. What you have in terms of components in OpenTelemetry is you have the OpenTelemetry protocol, OTLP. This is how you can centralize that information. You have the so-called collector, which is like a proxy to collect the information and then forward it. And you have the agents with an SDK to implement it in the various programming languages. And how OTLP looks like is you have a specification of how you can collect the information, either through gRPC or it supports JSON over HTTP or protobuffer as well. And you can actually do a simple request, and I'll just quickly show you how that works. So I will send from curl, not that you want to do that, you will want to use an agent in your actual applications, but just for the sake of illustrating how this works, I will use curl to send a very simple request to an OpenTelemetry collector that will then send it to the backend. Since I'm from Elastic, I will use the Elastic backend for that. It could be Jaeger or whatever other OpenTelemetry compatible backend you can have. So I will send that request, my one trace, to the collector, and just to quickly show you what that looks like, or actually maybe I should show you the JSON first. What was my file called? Okay, span, this is the name I want. So this is not even, or this is the minimum that you need to send to a backend. There are more fields that you probably want to have in practice, but this is the minimum set to get started with. So I say this is coming from a service that I name curl, because I'm sending this by curl. I instrument my application manually, and then I say this is the trace ID that I generated in my head, and a span ID. You can see these are not very random, but I just said I generated these, and I call it a span. And then you can look up in the spec what the kind and the status code, etc. are. Those are not so important right now. And then you can just curl that. This is the OpenTelemetry collector. It's running on its default port. This is where I'm sending that. Just to show you what the OpenTelemetry collector is doing. So here I'm saying I have in my OpenTelemetry collector, I have that running with the OTLP protocol, both with gRPC and HTTP. Since I was lazy and used curl here, we're actually targeting HTTP. So this is where we send that information. And then you have the so-called exporters. And in the exporters, you can say, where should the collector forward that information that you sent it? So this is then forwarding that information to an Elastic backend that I'm running on cloud. And hopefully everything works since I'm using this on Wi-Fi here. And if I go to my console and look up these requests, it now tells me I have sent 4 requests. I tried this before the demo. And one of these looks like this. So you can see this is when so these are the IDs that I used. This is I didn't provide the proper timestamp, so this is epoch. But you can see this is a manual request sent by curl, and this is the information that I have sent from my A-span with that ID, etc. So this is kind of like what is happening on the wire. But obviously, you want to outsource that to the agents to instrument your application because you don't want to generate that manually. But this is just to show what is actually happening on the wire to exchange that information. You can integrate into OpenTelemetry then in 3 ways, because I have used the OpenTelemetry collector. It's one of multiple ways. The first way you could integrate into OpenTelemetry as a vendor for the backend is you have the agent for every programming language, and then you have an exporter in each language that can then talk to the vendor protocol and send that to the backend. This is nice, but what is the obvious drawback here? You need to support every single agent. So for example, you need to write the exporter for the PHP agent, and maybe you don't really want to do that. Also because PHP is pesky, because that is actually written in C, unlike most of the other programming languages, where the agents are written in the same language. So while this works, it's not ideal in our opinion. What is easier is that you have this OpenTelemetry collector, which is like a proxy. So the gray stuff is the vendor-neutral OpenTelemetry. You forward the information to the collector, and then you only need a single exporter in that collector, and that can then export to Elastic or Splunk or whatever your vendor-specific backend is. So there is still vendor that's like the milk cacao color. That is the vendor. And that is what you export to the vendor. But all the gray stuff is vendor-neutral and just is standardized, so you don't have to care about the vendor here. This is nice because you only need a single exporter. It's still weird because you always need to run that collector. So what we support and what we also think that is kind of like the best way forward is that you implement the protocol of OTLP. So you implement the OTLP protocol in your backend, and then both the agents or the collector can send directly to your backend. That's what I'm doing in my demo, where I forwarded from curl through the collector, but on the OTLP protocol, to my custom Elastic backend. So this is what you can do, and then the only thing that is kind of like vendor-specific is you need to say like where to forward the information. Otherwise, it's all OpenTelemetry and vendor-neutral. So the only place really where you had anything that is specific to Elastic here in this example is that you say in the exporter, I'm using the OTLP Elastic exporter, since it's speaking that protocol. This is the endpoint, and then you have an authentication header where to forward that information. So this is all there is. So far, so good? Good. 11 languages are currently supported in OpenTelemetry in various degrees. So, for example, I think Swift and Rust, for example, are less well supported than, for example, Java, JavaScript, and Python. But they're getting there and making quite rapid progress, and a lot of companies and individuals are contributing to those. Just to give you an idea of how they are structured. So, for example, for Java, you have the OpenTelemetry Java, which is the library, and then you have the auto instrumentation, how you can instrument an application as a separate project. Because Java has this interesting concept where you have this -Java agent, where you can just add the agent at runtime to instrument the application and extract the information from there. So that would look something like this. You can see here in my environment variables here, I basically say this is the front-end service in version 1.0 in this environment, and I want to send this information here. And then all you do is you run your Java service, and with -Java agent here, you instrument the application, and it will then get whatever can be extracted by the agent automatically forwarded. You can also do manual instrumentation if you're using something that is not supported by OpenTelemetry yet. Here, I'm manually starting and ending a span, because whatever I'm doing here, I want to manually instrument just to get some more information out of that. What you could also do is you could add custom information. For example, here, I have a shipping application where I add a country code, the shipping method, the payment method. So anything that is like domain specific and you want to add to the requests, because afterwards you want to look up, give me all the things that use shipping by this specific company or use the specific payment version. By instrumenting that manually, you can add that metadata and then make that information available when you look at the request. So that will make it much more powerful with that metadata to figure out what is going on and why something is broken, coming back to observability, that it's not just about instrumenting, but actually figuring out what might be needed in your system here. The same thing for JavaScript. JavaScript has it broken out in 3 projects. You have an API, you have the SDK, and the auto-instrumentation for JavaScript. You need a couple of imports because JavaScript doesn't have this -Java agent concept, for example, which is the same for most programming languages. And then you could have here a manual instrumentation as well, where you start and end a span in JavaScript. But the concept is the same across all the languages then. So let's try this out. Actually, I hope this really works. This runs on my laptop, but you can tunnel through ngrok to my laptop and run some requests. So this is your chance to get out your phone and run some requests against my service, and I hope it doesn't die. You can do some shopping. You can buy a TV and other things on the cart, and then we'll instrument your calls in the backend. So hopefully this works. You need to accept that you can go through ngrok. It's fighting you? It's down. Oh no. Why up? That is very mean that it's, oh no, my network is down. Let me see, maybe I can go to my phone. This will be interesting. So we will see how this works out. Let's give it a wait, give me a second to try, if we can get that up on my phone, but I think the aux network is not good, so. Yeah, okay, that. Can you reach it now? No, it's still loading? Oh no. Okay, let me, I can demo it locally as well. Oh no, it's too many connections. Oh, okay. So it's the first time I'm trying this with ngrok. I'm afraid you were too successful. So what you should see, and I'm sorry, we will need to try this with a large audience again. So what you should see, you can add, for example, a TV to your shopping cart, and then you can check out, and then the checkout service will tell me the payment succeeded or failed. And you can see there is already a delay, which is maybe not so great. And we want to instrument that. And so that you can actually see something, I have something that generates load here. And when I run this, you will see little dashes and X's. Every dash is a successful request, and every X is a failed request. So this is just generating some load on my service, and hopefully this is I'm having enough bandwidth that I can actually upload that to the cloud backend where this is being collected, and then we can see how this does. So I show you some code first, by the way. So what I do in my application here is I run, for example, my front-end application, and all I'm doing, as I've shown you before, I'm just using OpenTelemetry to instrument that at runtime to forward the information and extract those requests. Okay. We are generating some requests, so we'll see how that looks like here. Hopefully my network is working. Okay, so we are getting some requests, and since I've tried that before, we can change the time frame a bit. So if in the last 1 hour we get some more requests. So, and now I can look at the front-end application. So, as you can see, this is now the vendor-specific part. OpenTelemetry instrumented the application. It forwarded the information to my Elastic backend, and now I can see here what is the throughput in terms of requests of my application. So right now I'm doing 10 requests per second. You can see which endpoints were called, how many failed transactions you have, and for example, which dependencies you have. So for example, my front-end application relies on the fraud service and the checkout service and has Postgres and Redis in here. But actually, let me show you an architecture diagram here. So your request comes in to Java. It checks with the fraud service if your request is fraudulent or not. If it's not fraudulent, you can go to checkout. It will then hopefully do the checkout. And all of those are instrumented by OpenTelemetry, which is then forwarding that information to the OpenTelemetry collector. And it's also collecting the information from Redis and Postgres to see what those are up to. So this here is all OpenTelemetry. And only from the collector to here, this is then when the vendor-specific backend is coming into place. So that's how those are combined. So well, looking at Redis, this is not where I wanted to go. Let's go back. You can look at the individual transactions. So you can see now that I've started to add more loads. We are getting 480 transactions per minute or so. We are also getting a few more failures again. And you can see which API endpoints might be the most interesting one. And then I, for example, could open this one here and then see the height here is, you can see these were 44 requests, which took around 200 milliseconds. And then you see some of my requests were slower. Like this one took like 1 second or so. And the red ones here, these are, for example, failed ones. And down here, you can see where did you actually spend your time. So my front-end service called my anti-fraud service and called the checkout service. And you can see where you spent most of your time. And you could click on one, and you can see I'm cheating slightly here because we are using a sleep in Postgres. That's why this is so slow. But you can see this is running a lot of queries, one after the other here. Maybe this could be optimized. But you can see basically where you spend your time and why this one here is adding that long break and why this is so slow. And the entire request is taking 1.2 seconds to figure out what is going on here. And you can see the metadata for this entire request, so you know what user agent is doing the request, what are the IPs involved, where are you storing the information, what is the host where this is running on, so this is on my laptop. You can see what has collected the information and how I instrumented the application. So this is running my Java application here, and I've instrumented it with the Java agent, and that is how we have extracted all of that information. So far, so good. Makes kind of sense. Okay. Sometimes you want some manual instrumentation like I've said before. So for example, here in my order controller, I have manually instrumented that I add some additional metadata to my requests so that I can actually figure out what is going on. And just by now you have a build dependency in the application to actually have these SDKs or APIs available, and now I can add additional metadata to my requests to actually collect those. And then, for example, I could go into a visualization here where I have all the metrics of the last 15 minutes or whatever, and then I could say I only want to, for example, the numeric ones because I want to show you a little graph. I could say the count of rejected orders, and I want to, for example, say, I don't want the median, but I want to have the cumulative sum. And you can see here, as we are getting more and more requests, this is the count of rejected requests that my application has been getting. And you could see, like, this is the amount, for example, that we have rejected, and everything that I have manually instrumented in my application, I can now suddenly see in the backend to figure out what is going on in my application. So it's not just like the database queries and the HTTP requests, but with the domain-specific information, you can also graph out how well your application is behaving overall, how much revenue you're making, or how much the revenue is going down if the latency spikes in your service, etc. You can, in your requests here, you can also see, for example, in my application, you can see the dependencies where I'm spending my time. So you can see here, most of my time is actually spent in that anti-fraud service, whereas Postgres, Redis, and checkout service are relatively fast in my application that is running. So this is probably the service where you want to figure out. This also has like this highest impact that we give it to show that this is where you want to figure out why it's so slow. You can see things like, these are all the JVM errors that I have been running into. If I make that time frame a bit larger, I think we should be getting some more. So these were all the unique errors that my system encountered in the last 24 hours. And then you can see how many times have they been happening. And you can figure out which ones you want to fix first. Or you could see in a service map, especially if you don't know so well how your application actually behaves. This is just from OpenTelemetry, you can figure out what is calling what and what are the dependencies in your system. If you have like 100 services, this can be quite helpful to see what is actually calling each other in the system. You can also see on each one of these components then, for example, here, the anti-fraud service, what is the latency of that system, what is the throughput and the error rate, and then you could jump into the specific service to see how that service is going. And here, since this hasn't been running so long, I'll move back to 1 hour. You can see here, this is the latency of that service in that time frame and where it's spending its time. It only has a single endpoint, so that was quite simple. So we have instrumented, we have tried that out. So far, all good? Then let's see what we can come up with. I hope I kind of made it clear why distributed tracing and OpenTelemetry, hopefully. So we had logs, and logs are good, but once you have more than one service in a monolith, logs alone are very hard to correlate, because then you might have like 5 open terminals where you tail-f some log file and you kind of try to combine what is happening where, and that's probably not going to work out so well anymore. Metrics are good, because to show you what is happening overall, but it's hard to figure out why something is broken. Requests are the nice addition to show you for one specific request, how did that entire request behave. And then you can also see the logs for that specific request, for example. And OpenTelemetry is, I want to say, the evolving standard that is everybody is chasing to actually make that happen. You don't have anything vendor-specific in your code base, but you just use the vendor-neutral OpenTelemetry in your code base and just configure the output, and that is where the different vendors are coming in then. What you can use today are mostly traces. This is by far the most stable solution and the one that is the most widely adopted. For metrics, I think it's possible. If that is really kind of like taking over from Prometheus is, I think, to be seen, and different people will have different opinions on that. But it's another option to have a standardized way to collect metrics from your application. Logs are kind of too early, and OpenTelemetry is also playing into observability in general. It's not just about logs, metrics, and traces, but OpenTelemetry is really about observability as a whole. And as we evolve as an industry, we will be adding more tools to that tool chain. So for example, what is kind of interesting right now, what lots of companies and also OpenTelemetry are adding is continuous profiling, potentially with eBPF, the extended Berkeley packet format, to instrument on the operating system level your applications, to continuously see, you normally get these flame graphs out, where do you spend your time in the calls. Things like production debugging, that you can at runtime say, I want to debug into this piece of code and get more information, is something that is also being discussed for OpenTelemetry right now. And then there to have a control plane that you can instrument your applications with a separate mechanism, that you can update the agents, not just by deploying the application new and adding your own agent, but by doing that, or to have like how much data are you collecting, that you can control all of that at runtime from OpenTelemetry. That is another big area that they're trying to build out right now. Since it's an open standard, there's a lot of movement and lots of people involved, but that's also why the standard is generally progressing quite fast. And all of these are happening in parallel, and more features are being added. Where the different vendors still come in, and why all the different vendors are happy to play along here, is that you still have the differentiation on the back end. So while the data collection is the same, the question is then, who has the most efficient way to store your data? Who has the best way to search it or visualize it? Who has the best alerting? I don't want to say AI ops, because that's a horrible term, but lots of vendors will say then, we have the best AI ops, so that's why you want to use us as a vendor backend. That is kind of like how these things come together, that you can collect in an open way, but then on the backend, you still have the different vendors playing together here. The other thing that sometimes is an interesting discussion is like, the standardization, is it really just more for the knowledge side, or is it so that you can switch out the vendor backend? Or let me rephrase that and make it kind of like a different question. Who is using an ORM, an object relational mapper, for their data store? Quite a few, I guess. Is anybody switching their production database actually? Most likely not. Very few people are actually switching out their production database while an application runs. Many people still use that OR mapper just because it's so convenient for the knowledge share. So it doesn't really depend on what database you're using in the backend, but from your application, it's very standardized and wrapped away. And maybe OpenTelemetry is kind of the same thing, that you have the instrumentation is very standardized, and then it doesn't matter so much what is the vendor backend. It doesn't necessarily mean that people will switch the vendor backend every year for their observability. It might be, but that is still something I think that the industry is trying to figure out, if that standardization on the instrumentation is more nice to have like one standard way and the knowledge share around that, or if you really want to switch out how you log or collect your logs, metrics, and traces and other information in the backend going forward. So that is kind of like to be seen. One final point. We are often just looking at our services when they are down or not behaving as they should, and it's very hard to figure out what should be happening here or how they should be behaving. And that is a bit like trying to learn how a marriage works just by looking at divorces, but that's exactly how we are treating our services. We often don't know the baseline of like what is normal and how should this be behaving, and not just when something is down and you see everything is red and you don't really know where to start. So an important point here is to make sure that you know how your systems behave in general, that you then can figure out what is not normal to actually fix that and put your services into a better place again. If you want the slides, they're available here, even though I want to update them a bit. And I also have some socks. If you have a good question, you will get a pair of socks. Any questions? And no socks for stupid questions. Though there are no stupid questions, but there are some. So, any questions? That will be a long throw, but please. Can you shout and I try to repeat? What I'm using for my terminal, I'm using fish. That is bat. So the actual question that I misunderstood, I'm using bat, B-A-T, and I have basically sim-linked cat to bat because I cannot learn new commands, but it looks much nicer. So yeah. So yeah, this is what bat looks like. This is the nicer cat. Which color do you want? Okay, you'll get yellow. I hope the forwarding works. Please. Yeah, it will be a while. Any other questions?
Yeah, you answered most of them, but. So some people were asking around, if there is a paid layer or you can do all this for free within the Elastic Stack offering.
Yes.
People were asking.
So if you have asked the questions, that's a good question. Maybe I should clarify that more. Come for the socks afterwards. So the only thing everything I've shown you, you can download and use for free. The only single feature that I've shown you that is not available for free is this one. Because this is like the manager feature. Like all the managers want to say, like, show me a fancy graph. And this is the only commercial thing that I've shown you in our backend. Everything else you can use for free, what I've shown you. So you can just download it, run it yourself, and get started with that.
Okay, I think you covered most of the ones that were mostly voted, but if anyone wants to ask, there's Arnau down there, and there's someone upstairs. Arnau, pots pujar? Hi algo a dalt, sí. Sorry, there's someone here, and then we'll go upstairs. Yeah.
Oh, can you hear me? Yes. So the question that we have is regarding sampling. So, we, at least in our side, we have a lot of traffic. It's here.
So sorry, yeah. Now?
So we do have a lot of traffic, so having all the logs and tracing for all the traffic is kind of like impossible.
Yeah.
So how do you have something to manage the distribute sampling in this setup?
Yes, so just for everybody, sampling is like what percentage of requests do you want to collect? The easy or stupid way is that the first service that gets the request makes a decision, and then you can define this percentage, and it says like, I collect 1% of the requests, and I assume I have so many requests that 1% is representative. So you can do that. With our own agents, for example, you can change that from Kibana at runtime, and you can basically update that number at any point in time. Otherwise, you need to specify the sampling in the service configuration. The other thing that I think that more and more companies are getting to, and I think that's one of our commercial features as well, is that you can do tail-based sampling as well, which is you collect all the requests, and you make the decision what do you store at the end by saying what is interesting. So you say, if there is an error or if something is slow, I want to collect it because I'm interested in those. I don't want to keep all of those hundreds of thousands of requests that took 5 milliseconds and were successful, because I'm not going to learn anything, and I'm just wasting resources by storing them. So head-based sampling is kind of like the standard and most widely used just because it's simple. Tail-based sampling is cleverer. The downside is that decision can only be made at the collector. So you need to centralize all the information, and then you don't store it, but you throw it away, but you have the overhead from collecting and on the network. Just for the storage backend, you don't have that overhead. But yeah, so sampling is generally supported. I think tail-based sampling is vendor-specific for most, and though I think that's the much smarter approach to get that done, actually, to only find the relevant and interesting ones. Which color did you want? Yellow or pink? Or I'll give you black. Okay.
And there was someone upstairs, I believe. Yeah.
Hello. Yes, one question. For front end, do you see that OpenTelemetry is a competitor for Google Analytics and its standardization of the metrics? This ability to, in some way, be flexible to send telemetry from any place. Do you see that it will make that everywhere is going to be used, or or you are seeing two different trends here?
So I think it's almost the other way around. I think OpenTelemetry can be to some degree a competition to Google Analytics. Because Google Analytics is just a small subset of what you want to collect in terms of information. I'm afraid we're kind of out of time. But otherwise, I could show you, on my personal website where you download the slides, I'm actually using tracing for the analytics as well, because the tracing collects like what user agent were you using, what page were you requesting, etc. And then I build a dashboard out of that, so I don't have Google Analytics anymore. I'm just extracting that information from the tracing information, because I kind of have it already anyway. Find me afterwards. I can show you on my laptop how that actually looks like, but you can use tracing for part of that information. It doesn't have all the bells and whistles of Google Analytics, but I cannot use those anyway, because Google Analytics is its own monster, so I'm trying to stay clear of that. And I don't want to throw up there anymore. Just find me afterwards and you'll get your socks. One final thing before you run off, so I can prove to my colleagues that I've been working today.
Oh, yeah.
Do you want to join?
Oh, yeah, definitely. Why not?
Cool. Thanks a lot.
Thanks,
enjoy
everybody.
the rest.
Thank you.